So there are some questions like from mechanics topic which I selected from some reference book. So there's a one question here. Two blocks of equal mass M are connected by massless string and pulley as shown in figure. Now the blocks are left to move. Then the force exerted by pulley on the clamp is this one. Find the value. You find the value of K is there. That is the question. So let's start here. So it's straightforward. Like first of all, we'll calculate the acceleration. So we know that net forces those are acting. So on M mass there's a mg here, and on this M mass there's a mg sine 30. So the acceleration is the net force. So mg minus mg sine 30 divided by total mass. So it is mg by 2 upon 2m. So this coming as g by 4. Now what are the tensions here? So if we see this mass here, so on this mass the equation is is going downward, right? With the A acceleration, this is going upward with the A acceleration. So the equation is mg minus t equal to mass into acceleration. So the tension is equal to mg minus ma, and a is g by 4, so which is like 3 mg by 4. Now there is a tension here. Now if we draw the FBD of pulley, so FBD of pulley. So pulley is connected with the strings, right? So there are two strings here. Okay. So like you can see here, there's a tension T here, there's a tension T. So there are two forces acting on the pulley from the string side. So the resultant of these two strings, these two tensions, will be in this direction, and that is the force which is exerted by the pulley on the clamp. Okay, as you can see the direction here, the resultant force. Okay, so that force exerted by the pulley on the clamp, So we need to find the tension, the resultant of these two. So the angle between these two tensions, so this is 30, this is 90. So like I can say this angle 60. So the angle between them, these two tension is 60. So resultant will be root 3 times tension, right? So resultant force, the T resultant, okay, that is root 3 times T. Now if we put the value of T here, so root 3 mg by 4. Now if we compare this force with this one, so we can see that K value is 4 only, and that is the answer, right? So I hope you understood. Okay, let's move to the next question. This question is like from a relative motion, okay, river boat problems. A boat has to cross a river as soon as possible. In doing so, it takes 4 seconds, less than it if it travels by shortest path. Let the width of the river is d, velocity of river is this one, and the boat can travel in still water is this one. So the variables which we have is Vr equal to 8 meter per second, velocity of river with velocity of man with respect to river, the boat with respect to river, right? So that could be man also, sorry. So velocity of boat with respect to river is 17 meter per second. So the formula we have with the T minimum, what is the T minimum formula? So d by v mr. Okay, and this time is less than the time taken by the boat, okay, to cross the river in shortest path. So time taken to cross the river in shortest path, so that like we have a condition. Okay, so the condition, so first of all, like I'll just draw the diagram just for reference. This is my VR, this is VMR. The resultant of these two is my VR. This angle I'm taking as theta. Okay, so the shortest path, the condition for the shortest path, right? What is the condition for shortest path or minimum drift, right? So that is like cos theta equal to minus VR upon VMR, and the time taken in this condition is d upon VMR sin theta. Okay, so we can calculate cos theta value here. Minus VR is 8 and this by is 17. Now from this one we can calculate the sin theta also. Now sin theta will be coming as 15 by 17. Now if you put the value here, okay, now let's before putting the value, let's see the relation, like what is given here. So as according to the question, in doing so it takes 4 seconds, less than if it travels by the shortest path. That means this d by VMR is equal to d by VMR sine theta minus 4. Okay, so it takes less than 4 seconds less than this one, right? Now we'll just put the value. So d by 17 is equal to d by 17 into 15 by 17 minus 4. Now d, so we'll go there, so we'll create common 1 by 17 minus 1 by 15 is equal to minus 4. So it will come as it's like minus 2 by 17 into 15 equal to minus 4. This 2 times, so d by 17 is equal to 2 into 15. Okay, I'll just took this 15 to the right hand side. Now I need a 170 here, right? So for that purpose, like I'll multiply and divide with 10. So 110 will come here, 110 will come here. So that 10 will go that side. Now 15 into 30 by 10, which is equal to 3. So that means d by 170 value is 3. And that is the answer. Okay, so that is it. Okay, let's move to the next question. Okay, the next question is again like based on the force, spring force this time. So there are 4 springs, identical springs, each constant is k. Initially they are in natural length L, the gravitational force is neglected, okay. Mass is slightly displaced by distance x along the line perpendicular to the plane of the figure, and this is the force. Okay, after release, like what is the net force acting on? So the M mass is released perpendicular to the plane. Okay. So let's say that this is my like z direction, okay, and this is my x, okay, like this is x, this is y. Okay, so just see one spring here because all are like identical, so all will apply same force. So this is the mass initial position, it is displaced, okay, it is displaced by x, okay, this is x-axis. So it is displaced by x, so the spring is like that, now the spring will be like this. So this length is L, so let's say this length is L plus y, where y is the extension in the spring. So the spring will apply force along the spring, that is, let's say FSP. Now to find the net force, we need an angle. So this, let's say this angle is theta, so the component of FSP in this direction. So FSP is in this direction, we need a force in this direction. Excuse me. So FSP cos theta, right? Now this is the force exerted by one spring. So there are 4 springs. So all will apply same force in the same direction. So that means the resultant force, okay, resultant force towards the origin is equal to 4 times FSP cos theta. Now I'll just put the value. So 4 into FSP is ky, okay, extension is y, and cos theta from this triangle is x upon L plus y. Now we need to remove y because this is the assumption, right? So how can we remove it? So see the right angle triangle. So I'll apply the Pythagoras theorem. So x square plus L square equal to L plus y whole square. L square plus y square plus 2ly. It's cancelled. X square is equal to y square plus 2ly. As you can see that the spring is stretched, slightly displaced. Okay, that means that extension in the springs is very less compared to that length. So y is very less than capital L. So what I can do, I can neglect the higher order terms, right? So x square will be equal to 2ly. Now from here y equal to x square upon 2l. Okay, now I'll put the value here. So f is equal to 4k x square by 2l x upon, and L plus y again becomes L. We can write it because y is very small. So the proportional sign, that the proportional to x to power n. So you can see here that f is directly proportional to x to power 3. So that means n value is 3, and that is the answer. Okay, so that's it. Next question. Okay, next question is based on again relative motion. It's rain problems. Rain is falling with a velocity 4 I minus 3 j cap. That means if we draw the velocity of rain, so 4 I minus 3 j cap, that means it is this one with 5 meter per second. So we have a VR now, and this angle will be 37, right? As you can like calculate from this vector. A person starts moving with the acceleration 1 meter per second square in this direction. The difference between two time instants in the second in which rain appears to fall 45 degrees with vertical is. So first of all, when the time it is moving accelerated, right, the person is accelerating, the velocity will increase. So as the velocity increases, this velocity v, velocity of rain, will shift to this side, keep on shifting, right. So initially the angle is 37. Now it will increase the value, increase its speed. So let's say this velocity of rain comes to this side. This is now VRM, velocity of rain with respect to men, and at this instant the speed of the person is v. So v we can write as u plus at starts. So initial velocity is 0, a is 1 into t1. That means the velocity is t1 when VRM is making 45 degree angle. Okay, now this is the first scenario. So what we can say here, VR is the resultant, so we can let's like equal the components here. So VRM, see that how am I doing? VRM sine 45, the vertical components I am equating is equal to 5 sine 37. Okay, so from here we can find the VRM value. So VRM is 1 by root 2 equal to 5 into 3 by 5. So VRM is equal to 3 root 2. Okay, now let's move to the, okay, T1 we need to find, right? Okay, let's equate the horizontal components. So VRM cos 45 plus T1, that net velocity, is equal to VR, that is 5 cos 37. So VRM cos whatever we can write it directly, 3 plus T1 is equal to 5 into 4 by 5. So T1 is coming as 1/7. Let's do the same thing with the another scenario. Now the speed is increased. Now this becomes T2. Okay, this is VR. Now VMR will be this one. This will be the second scenario. It is VRM, right? Now this angle is 45. Okay, 45 angle with vertical or horizontal, whatever it is. Now again we'll equate the components. So VRM still like VRM will be equal to same, like it will come 3 root 2 again. Okay, you can check it from here. So I'm not going to do this thing because the components are equal again, right? VRM cos sine 45 equal to VR sine 37. Okay, because this angle is 37. Let's equate the horizontal components. So this time that VRM is opposite, right? So T2 minus VRM cos 45 is equal to VR cos 37. Now T2 minus, so this value is 3 is equal to VR is given 5 into 4 by 5. See, so T2 is coming as 4 plus 3 is 7. Now what is the interval? Interval they are asking. You know, the difference between two times. So T2 minus T1 they are asking. So T2 minus T1 is 6, 7. And that is the answer. Okay, let's move to the next question. System shown in figure, velocity of sphere A is 9 meters per second, the speed of sphere B will be. Okay, first of all, I'll try to change this diagram, okay, just for my convenience. You can do this thing also, because like the planes which you are seeing here, that if I assume this is X, then this will be Y, because here we don't need to apply the forces, right? We just need to apply the geometry and we just like apply the wedge constraint. So 1 second. So here we are going to apply the wedge constraint here. Okay, so I'll just brief it like what is the wedge constraint. So wedge constraint basically we apply that at 2 contact points. So whenever two bodies, 2 surfaces are in contact, let's say these 2 bodies are in contact and they remain in contact. So what do we say? That if they remains in contact, that means the velocity of separation or velocity of approach is 0. Means they will have same velocity along this line perpendicular to the contact surface. That is the wedge constraint. Okay, So what I'm doing here, so just like I don't need to apply any force here. So what I'm doing here, so this is axis, so this will be y axis because the angle between them is 90, as you can see. So what I'll do here, so I'll just rotate the whole diagram. So I'll rotate like in clockwise and keep rotating it like until the one plane, this becomes x and this becomes y. Okay, so that's we can do now. Now I'll draw the diagram. So this is one sphere, this is another sphere. Okay, this is one center. Okay, so that is it. Okay, so that's how the diagram is now. This see the directions, the velocity. This is A, this is B. Okay, this one is given y 5. This I'll assume as r. Up see 9 meter per second is velocity parallel to the y-axis, right? See, so that means this is 9. And what is my y now? This is y-axis, right? So parallel to 9. So that you have to convert, right? Otherwise, like the questions will be changed. Just 1 second. I will just reduce this. Okay. So it is 9. Okay. What are other things? 17 meter distance. So this one is given as 17 and this one is given as 19. Okay, now I just need to calculate some variables. Okay, see, this is 5. Just see the geometry. Okay, I'll use the different color, otherwise this is 5. Okay, so that means this is 5. So that means this is 12 now. Okay, this is 12. This is 5 plus r. What is this? 5 plus r. And what about this one? This is r. So this is 19 minus r. Okay, so you can see a right angle triangle here, PQR. So in PQR I'll apply the Pythagoras theorem. So triangle PQR. So what is it? So PR square is equal to PQ square plus QR square. Okay. So I'll apply. So PR square is, what is PR? Is 12 square. PQ. What is PQ? Sorry. 1 second. PR is my R plus 5. The whole square equal to PQ is 9 square. So 9 is 12 square plus QR 19 minus R whole square. Okay. Now I'll just open the whole square. So the whole square is R square plus 25 plus 10R equal to 144 plus 19 square is 361 plus R square minus 38R. So R square cancel here. I'll just solve it. Now this subtraction and all, like 38 plus 10, so it becomes 48R is equal to 144 plus 361 minus 25. So it will come as 480. Okay, so R is coming as 10 meter. So now we have a R 10 meter. Now we'll just see the right angle triangle again. Now this is 12. This is 19 minus R, which means 9. And this R plus 5, which is 15. Okay, speed of B. So now we can calculate the angle. Okay, now I'm going to apply the wedge constraint, which I can apply now. See now, contact points. Where are the contact points? So this is the contact. This one and this one. Okay. This is one contact point, this is one contact. So in this diagram, if one is coming downward, so other will go like this. That means if this has a velocity downward 9 meter per second, as because like whole body is going downward, so this point also will move downward and this point will move horizontal with V. Okay, now I'll just see the angles. Okay, Okay, so now let's assume one theta. So let's say if I assume this is theta, that means this is theta, right? So this is theta, and this will be 90 minus theta. So the component of v along this direction, along this line we have to take component. So it is v cos theta is equal to 9, and it is 90 minus theta, right? Cos 90 minus theta, which is sin theta. So v cos theta. Okay, what is cos theta now? So see, right angle triangle, this is theta, right? Cos theta is 9 by 15 is equal to 9 into sin theta is 12 by 15. Okay, v is coming as 12 meter per second, and that is the answer. So I hope you understood, and that was the last question. So this is from my side. Okay, so that's it. Thank you.